Hey there. This skill that you're working on here is pretty much the opposite of the last one we were doing, where we were multiplying polynomials. So taking something like 5k times k squared plus 2k and distributing through there. So we get 5k times k squared, which is 5k cubed, and then 5k times 2k is 10k squared. So we're pretty much going to be going backwards from that, saying like, well, where did this come from? That's what we're doing. It's called factoring. We're trying to factor out the greatest common factor. Basically, take out anything that we could from this, saying like, what do these things have in common? So looking at the numbers there, 5 and 10 both have 5 in common, so I can take that out of them. And they also, this is 5 times k times k times k, and this one's 2 times 5 times k times k. So we're taking out the 5, they both have a 5 in them, and they also both have 2 k's in them. So I'm going to take out 2k, so k squared, and say, well, what did this 5k squared multiply to get to this? So notice that there's still 1k left here, so I need to multiply by 1k. And then on the second one, so it's positive, since that's positive up there, but there's still a 2 left here, so 2. That's one way to think about it. Thinking is like, what do they have in common? So they both have a 5 in them. They both have 2 k's. This one has 3 k's. This one has 2. So we take out the smaller of them. So that comes on the outside. And then what's left? 5k squared times what is 5k cubed? Well, I need one more k, so there's the k. And 5k squared times what is positive 10k squared, so we need a 2 there, 5 times 2 to get us that. So if I distributed this, I'm going to get right back to where I started. So that's basically what we're doing here. So if I have 8k cubed plus 6k squared, I'm going to say, well, so one thing you can do again is break it down, that 8 is 2 times 2 times 2 times k times k times k. And then we have plus 2 times 3 times k times k. If you really need to see it like all the way broken down, this is one way to do it. And say, well, what do they have in common? Well, they both have a 2. And they also both have 2 k's. So that 2 and those 2 k's get to come outside. Always on the outside of the parentheses, so 2k squared. And then what's left on the inside? So again, it's really what we're going to do is if I list things on the outside, what's being distributed, and what's it multiplying? So 2k squared times what is 8k cubed. So to go from 2 to 8, I would need a 4. And to go from k squared to k cubed, I would need another k. And then a plus, or whatever the sign is, I guess. And then the other side, it would be 2k squared times what is 6k cubed squared. So to go from 2 to 6, I would need a 3. That's me a positive 3. And to go from k squared to k squared, I don't need anything, so I don't need any more k's. So it's actually done right there. So this would be the factorization of that. So that's what I would type into my box here that would be down here. Make sure you're using the right variables, and make sure just getting the exponents and the parentheses in there, just like this. So again, the idea is like, what multiplied to get this? What was distributed into some other expression to get this? So let's try another example. Here we have one that's got 3 terms. So 6k to the 5th plus 6k to the 4th plus 6k cubed. So I do have to look at all 3 terms. I can't just look at 2 of them and say, what do these 2 have in common? I have to look at all 3. It's constantly they all have in common. Of course, they all have a 6 in them. This one's actually not too bad. And then this first term has 5 k's, and this one has 4 k's. This one has 3 k's. So what do they all have? They all have at least 3. So I can take out 3 k's. So 6k cubed is going to come out. Well, what multiplied 6k cubed to get what we have? And so again, the idea here is 6k cubed times what is 6k to the 5th? Well, I need 2 more k's. take that, I'm going to need 2 more k's, k squared. Into the next term, I have the 6 already, 6k cubed times what is positive 6k to the 4th, so I need to change the 6, and it's going to be positive, whatever it's going to go here, and then I need 1 more k, so it's going to be plus k, so k squared plus k, and the last term, 6k cubed times what is 6k cubed? Well, 6k cubed times 1 would be 6k cubed. People in the past, there's some students where they just don't put anything, like, oh, it's the same thing, I don't need anything. You actually do need something, you need a 1. So, the idea, like, make it a little bit simpler, like, if I had something like x squared plus x, and then I just take an x out and say, well, that's x times x, and then, well, since x is already x, I don't need anything else. I'm just saying, like, that this equals that, and it doesn't, because x times x is just x squared, and it doesn't equal x squared plus x, and so we do need that little bit of extra thing, x plus 1 here, so x times x being x squared, and x times 1 being x. Now it's equal to that. So don't forget about the little 1 there. It's actually important. Sorry about sniffling. Alright, here we got 4t to the 4th plus 8t cubed plus 4t squared. So one thing about the thing they all have in common here, so 4, 8, and 4 all have 4 in them. And then the first term has 4 t's, second term has 3 t's, and then the last term has 2 t's. So the most they all have at least 2. So I can take out 2 t's. And I guess when I ask myself, 4t squared times what is 4t to the 4th? I don't need the 4, that's already got that. I need 2 more t's. So I'm going to have to do 2 more t's, so t squared. And then 4t squared times what is 8t cubed? So to go from 4 to 8, I need a 2. That's going to be a positive 2. And to go from t squared to t cubed, I need 1 more t, so 2t. And then 4t squared times what is 4t squared? Well, 4t squared times 1. So there's that 1 again. So that's what you would type into your box there. And last one here, so I got 40 s to the 8th minus 30 s to the 7th minus 40. So what do they all have in common? So 40, 30, and 40 all have 10 in them. We'll factor out a 10. And the first term is 8 s's, the second term is 7 s's, the last term is no s's. And as far as what they all have in common, they don't have any s's in common, since this one doesn't have any s's to take out. So all we have to take out is 10. So 10 times what is 40s to the 8th? So I'll need a 4 to get to the 40. And I'll need those 8 s's, so 4s to the 8th. And then 10 times what is negative 30s to the 7th? So I need to go from 10 to 30. I'm going to need a 3. That's going to be a negative 3 since that's negative. And I'll need those 7 s's also. And then 10 times what is negative 40? Well, 10 times negative 4 is negative 40. Oops. So the idea is if I distributed this 10 back in, I get right back to where I started. That's what we want. So I'm going to type in my box here. So kind of common mistakes. So like, if I would have 5 out of all those, I would have had 5 times 8 s to the 8th minus 6 s to the 7th minus 8. This is also a factorization of this. 5 times all these things would get me back here, but it's not the complete factorization. It's not the greatest common factor. So there's something bigger than this. So this would be incorrect if you type this in. What do you notice here is like how do you know if there's still more to do is that 8 and 6 and 8 all still have a common factor of 2. So that 2 needs to come out, right? And of course 5 times 2 would give me the 10 that I was supposed to take out the first time. So after you take pick out what you think is the biggest things, and then it's a good idea to go back and look inside the parentheses and say, well, did I actually take out everything I was supposed to? Oh, these still have something in common. Oh, okay, I need to take out more. Right? So that's a pretty common mistake. And here they say this bit about if there's no common factors, you just retype the original problem. So what that would look like is if it said something like 7x squared minus 5x plus 10. So as I look at these numbers, they don't all share anything. Sure, 5 and 10 both have a common factor of 5, but 7 doesn't have a common factor of 5. And these two both have an x in it, but this one doesn't have an x in it. So this would not be factorable with the greatest common factor, so I just retype that into the box like I said to. Well, that's it. Hopefully this will be a good start with GCF factoring, which is going to be an important skill for us to know. I'll see you Monday.